the pH concept. I'm sure we all have heard the word pH or maybe may have tested the pH of solutions before. But what is it? Well, pH is just a mathematical operation on the hydronium ion concentration. To be exact, it is the negative logarithm of hydronium ion concentration. Before we go into the details of pH, let's talk about the P here. The lowercase p something in scientific field means the negative logarithm of something. H here means the concentration of protons. H, the concentration of protons. The concentration of protons in solution is the same as the concentration of hydronium ion concentration. We know that protons do not exist in solution. It exists in the way as a hydronium ion. So P means negative log of something. Now, because hydronium ion concentration is related to the acidity of a solution, therefore, pH is related to the acidity of a solution. Now you may want to ask, wait a minute, if we can use that to represent the acidity of a solution, why do we even bother to take a negative logarithm of it so that we get a number that is called pH to represent the acidity of something? Why do we do that? Or why do scientists do that? Well, that is because for many solutions, for most of the solutions, the concentration of a hydronium ion will be in the format like 2.54 times 10 to the power of negative 6 or 3.38 times 10 to the power of negative 10. They will be in the range like that. Using those numbers to evaluate the acidity, basicity, to compare them, to operate them, is not a fun thing to do. Not most people are not comfortable with numbers like that. So what scientists did is that they take a negative log of a number like that. If you take a negative logarithm of a numbers like that, you're going to get a number like 3.5, 4.7, 11.1. You're going to get numbers like that. Numbers like this are a lot compact, are a lot easier to look at, to compare, to operate. Does that make sense to you? That is why scientists took a negative log on the hydronium ion concentration so that they can convert the acidity or the hydronium ion concentration to a more compact format. So pH is a compact way to represent the solution acidity. Due to the negative sign here, when the hydronium ion concentration increases, pH will decrease. So pH decreases as the hydronium ion concentration increases. Remember, hydronium ion concentration, proton concentration, the same thing. Therefore, the lower the pH, the more acidic, because the lower the pH, the higher the concentration of the hydronium ion, the more acidic the solution. Usually, pH is between 0 to 14. Well, once the hydronium ion concentration is given to calculate the pH, you just take a negative logarithm of the hydronium ion concentration. However, in some cases, the pH of a solution is given. Then you need to calculate the hydronium ion concentration. How do you do that? Well, hydronium ion concentration equals 10 to the power of negative pH. Why is that? Well, I am not going to explain this here. What I can tell you is that this formula and this formula, mathematically, they are equivalent. They are the same thing. They are two different ways to represent the same mathematical concept. So you don't need to dig out why, just memorize this. Well, we just introduced the pH concept. Now we're going to introduce another concept that's called pOH. Well, you may not have heard this. It is right. pOH is not as common as pH. It is not commonly used. However, it is used in chemistry for this class, for ourselves, for scientists. It will make your life a lot easier in some of the calculations you're going to do in this chapter. So pOH by concept, but the definition here we just talked about, it is the negative logarithm of the hydroxide ion concentration. Remember we introduced Kw in the last episode. Kw is the product of hydronium ion concentration and hydroxide ion concentration, which is 1 times 10 to the power of negative 14 at 24 degrees Celsius. Do you remember that? Well, because of this, pH plus pOH will always equals 14. Okay, again, if you're interested, you can dig out the mathematical reasons, okay, the math in the back of this, why pH plus pOH equals 14. Well, you don't have to. That is the reason why pH plus pOH equals 14. Therefore, for some solution, if pOH is given, pH will be 14 minus pOH. If pH is given, pOH will be 14 minus pH. What are you trying to say, Dr. Yang? Where do we use this? We are going to see this quickly. It will make your calculation a lot easier by means of pH, by taking advantage of pOH, I mean. Here we go. Calculate the pH of each of the following solutions. The first one, hydronium ion concentration is given. So pH equals negative log of hydronium ion concentration equals negative log 1.0 times 10 to the power of negative 4, which is 4.00. Wait a minute, Dr. Yang. There is only one. There are two significant figures here, but in your answer here, there are three sig figs. What's going on? Well, this rule for the significant figures for logarithms is unique. We haven't talked about that before, but I'm going to introduce it here. Significant figures in logarithm calculation, you keep the same numbers of digits to the right of the decimal as the number of sig figs in the original number. In the original number, we have two sig figs. Therefore, in your logarithm calculation, you keep 2 digits after decimal. That's what this statement is talking about. All right, let's work on B. Well, the answer key is shown already, but let's assume it is not there. In the second one, hydroxide ion concentration is given. However, it is asking you for pH. Well, with hydroxide ion concentration, we cannot get pH. What we can get is the pOH. So we're going to take the pOH, a negative log of hydroxide ion concentration. Whatever it is, then you're going to pH. Once you get that number, you're going to use pH equals 14 minus pOH. So I didn't do the calculation on this one here. You should. You plug this number in there and take a negative log of 0.04. And then you use 14 minus pOH, you get the pH number. So I do have the final answer here. Another exercise, the pH of the solution is given. What is the hydronium ion concentration? All right, hydronium ion concentration equals 10 to the power of negative pH, which is 10 to the power of negative 5.85. You plug those numbers into your calculator, you get a number format in scientific notation. So it should be 1.4 times 10 to the power of negative 6. Again, as you can see, you have in the pH, you have 2 digits after decimal. In the original answer, here, you should have 2 sig figs because pH is a logarithm. Well, let's talk more about the range of pH. Keep in mind, this is what we know already. For a neutral solution, hydronium ion concentration, hydroxide ion concentration will equal, and each one of them is 1.00 times 10 to the power of negative 7. For acidic solution, hydronium ion concentration is higher than that. For a basic solution, hydronium ion concentration is lower than that. We are focusing on the hydronium ion concentration right now because pH is negative log of hydronium ion concentration. So if solution is neutral, which is this one, pH will be 7. You take a negative log of that, negative logarithm of that number, you're going to get 7. So pH 7 is neutral. If pH greater than 7 is basic. The greater the pH, the less acidic. The lower the pH, the more acidic. So if 7 is neutral, lower than 7 will be acidic. Higher than 7 will be basic. The higher the pH, the more basic. The lower the pH, the more acidic. All right, this one's right. Trying to use a chart to show us the relationship between the pH values, the hydronium ion concentration, and the hydroxide ion concentration. Okay, when pH goes higher, and higher, hydronium ion concentration becomes lower and lower. Okay, hydroxide ion concentration becoming higher and higher. So lower pH, higher hydronium ion concentration, lower hydroxide ion concentration. Taking this opportunity, I put a statement here. This will make some of your calculation a lot easier. It will make some of the questions in the exam or quizzes be answered very fast, quickly. So if the hydronium ion concentration is 1.0 or 1.0001 times 10 to the power of something, if the coefficient is 1, be it 1, 1.0, 1.00, if the coefficient for the hydronium ion concentration is 1, then pH is N. Just the negative N becomes N. That's it. Quickly, let's do some practice. Calculate the pH of these solutions and predict acidity. All right, hydronium ion concentration, the coefficient is 1, so pH is 3 in this case. pH 3, acidic. Well, the second one, it didn't give us the hydronium ion concentration, it gives us the hydroxide ion concentration. The coefficient is also 1. If that is the case, pOH is actually 11. So that number without a negative sign will become the P something right away. So pOH is 11. Therefore, pH is 14 minus pOH, which is 3. Again, acidic. The third one, hydronium ion concentration, well, the coefficient is 1. Therefore, pH is 7 right away. Neutral. I will leave the last 3 for you to do. All right, pause the video, answer the question, get the pH, get the acidity, and unpause the video to check the answer keys. Here is the answer key. See you next time.